Hello, in this video, we will be seeing how to merge two sorted arrays that are given to us and return the merged array that is sorted from these two inputs that we receive. We will be building a solution in JavaScript and also compute the time complexity and space complexity of the solution. We will be given an input array nums1 that will look something like this 1 2 3 having three zeros at the end. We will get a m value that determines the length of the input that we have received. So in this case, m is going to be 3. Then we also receive another array nums2. This is going to be having a length of n that is going to represent the number of values that it has. Now, even though m is 3 in the case of nums1, we still have trailing zeros here. Why do we have this? This is because we aim here to merge the two arrays that we have received, and they have to be merged into nums1 itself. And this spaces that are having zeros right now will be then used to also merge nums2 into nums1 itself and then sort them in the ascending manner. And the inputs that we have received are already sorted in the ascending order itself, both nums1 and nums2. Then we have to merge them and make sure that the order of being sorted in ascended order remains. And that's the whole problem statement. Now let's jump into the solution aspect. To solve this problem, we'll be using pointers, and with these pointers we will make sure that we traverse the length of both the inputs that we have received, that is nums1 and nums2, and try to make sure that when I override nums1 with the values from nums2, the order of being sorted is still maintained. And to do that, I will use a pointer 1. This pointer 1 will be at the end of my nums1 array, which has the length of m. So I will put my pointer 1 here. The pointer 1 goes here and not here because the input length is actually 1 2 3. Only thing is that we have the spaces to make sure this nums2 gets merged into nums1 correctly then. And I will use a pointer p2 that will also point to the end of my nums2 array. So I will have a pointer p2 here pointing here. And with these two pointers, I will iterate and keep on comparing the values in each array, and whichever is greater, I will then put it in my nums1 array from backwards. So I will go from backwards towards the start of my input. That will make sure that I am making sure that the higher values are at the end, towards the end, and then you come towards the start and the values then get reduced. And to do that, I will use another pointer. So I will use a pointer p that will be pointed at the last position in nums1 itself, and this pointer will go from the last position towards the start, and we will keep going in this direction while making sure that both these pointers that I have are within their bound itself. So once p2 crosses the bound of this value and reaches a -1 index, I stop from p2. And I also need to keep making sure that my p1 is also greater than or equal to 0, so that I don't cross the bounds that I have. And at each execution of my loop that I will be using to go from the end towards the start, I will just make the comparisons between this and this and make sure whichever is the highest one gets updated, and then I reduce the counter of p, because then to be sorted in the ascending order, towards the end I need to have the higher values, and then towards the start I need to have the lower values. And that's the core of the solution that we are using. And let's begin. What we will do is, we have a pointer p2 here, we have a pointer p1 here. Let's compare p2 value, which is 6, and p1 value, which is 3. Which one is greater? From these two, the value that p2 holds is greater. That's why I will override the value I have with this. So I will make sure I put 6 here. Now I have picked one element from my nums2 array. The aim here is to pull everything from nums2 and make sure merged it into nums1. So once I have picked one element, I can safely move the pointer, and I will move the pointer backwards because I will try to keep on picking the elements from my nums2 array and fuse them into nums1 and then reach the end here and stop from nums2. And then I will move forward. Again, I will check what is the value in nums1, which is 3. I will compare it with my 5. 5 is still greater. So then I will override the 5 here. I will again move my pointer. So I just have one more element left that I have not considered from my nums2. And with this, I will again check what is my p1 value. P1 value right now is 3. And what is my p2 value, which is 2. Which one is greater? The value now at the p1 index is greater. And because of that, now I will say pick the value at my p1 index. And now my p1 will reduce and move on to the next in the hierarchy. Then I will again do the checks. I will say compare p1 and p2. If p2 is greater, just pick p2. And I will pick p2, and this 3 becomes 2 now. And now what will happen is my counter will be here, and it has crossed the bounds that I have with me. And because it has crossed the bounds, I am no longer able to compare anything from my nums2 because I have already consumed whatever was needed, and I just stop here. And at the end, I will be left with this array that I have, which as you can see is merged. Both nums1 and nums2 values exist in this, and this is a sorted array in ascending order. And that's it. Now let's convert whatever we have covered so far into code, and that will look something like this. We will say that we want to use two pointers, p1 pointer and p2 pointer. So I will say let p1 is equal to the length of my nums1 array, which is m minus 1, so that I point to the last index. Then I will have my p2 pointer that is going to be n minus 1, so that I also point to the last element in my second array that I have received. Then I will go in the loop, use this p pointer that will go from the end towards the start to make sure I will maintain the ascending order of the array. And to do that, I will just say start with p at m plus n minus 1, because it has to start at the last position, and then once both these arrays are merged, so 3 plus 3 is 6, so the length is going to be 6th, and that value has to be greater than or equal to 0. I cannot go into a negative value here, and I will just keep reducing the counter that I have. Next, after this, within the check, I need to make sure that my p2, whenever is crossing the bounds, I have to stop. So if p2 is less than 0, I will just break my loop, and that would mean that I have sorted the array and merged as well. Then I will just put a check which will also make sure that the p1 value is also not crossing bounds. We have to ensure both the p1 and p2 pointers are within the bounds of the array as we are keeping on decrementing them. So if p1 is greater than or equal to 0, and let's say we try to compare now, which is higher. The reason for comparison is to maintain the sorting order, and I will just say nums1 of p1 that I have has to be greater than nums2 of p2. If this stays true, then I will just override my nums1 value at the pointer I am currently at with the p1 value that we have found, because the value at p1 is greater than the value at p2. So I will just say nums of 1 and whatever p1 value is that, and then you decrement, because then you have picked the value and move forward to the next one. So I will just decrement this one. Otherwise, what we can conclude that p2 is greater, and if p2 is greater, then we override the override happen only in nums1 because that's the array that we have to modify. We don't have to return anything, we just modify nums1 in place, and that's why we have the additional space in nums1 already. And then we will just say whatever nums2 value you have at the p2 pointer, you pick it up and then you reduce the counter. And that's pretty much it in terms of the logic that we covered so far. And the time complexity that is going to be involved here is going to be big O of m plus n, because we iterate via this pointers p1 and p2 both the arrays that we have, and in the worst case we will be iterating the entire length of both the arrays that you have received. And the space complexity that we have here is going to be big O of 1, because the space occupied is only by the pointers that we have, which are p1 and p2, and we will then in place modify nums1, so there is no additional array that is being used here to try to reach a solution. And that's it. Thank you for watching. Please like and subscribe.